Bismillahirrahmanirrahim. Today's video will be solving question number 4 from December 2019 exam of Canadian Professional Engineering Technical Exam. And this is a very simple question. We have to, first of all, in the first part, we have to find the Thevenin voltage and impedance at terminal AB. Then we have to calculate Z load, which is to be connected across the terminal for maximum power. And then we have to calculate the maximum power, the value of maximum. I've just drawn it a little bit neatly. This is taken actually from Mr. Alexander's book. The values are changed. Okay, so the first part, to find the Thevenin voltage and impedance, we'll first of all find the impedance. So if you recall, for impedance, we short circuit the voltage source to find Z Thevenin by setting the voltage source to 0. So this has to be set to 0 or short circuited. It will become like this. And now we'll just draw a couple of circuits to make it look easier. So you can see this is shorting D and F. I've drawn it like here. Then I move the two arms outside. So it becomes like this. And now you can see these two are in parallel because these 2 points are shorted, same point. And similarly, these two are parallel. So we can call them Z1 and Z2. This is Z1 and this is Z2. And then the value of Z1 is, from here you can see these two in parallel. Solving, we get this value. And similarly, Z2, these two in parallel. Solving, we get this value, second value. So the total impedance, that is Z Thevenin, is Z1 plus Z2. Adding these two values, the answer is 4.38 minus J 2.57. So Z Thevenin we have found. Now let's find V Thevenin. We have just redrawn this circuit in a manner which looks more convenient. We have also added two currents, I1 and I2. And we can, by solving either of the loop, upper or lower, we can find V Thevenin. But first, let's calculate or find the currents I1 and I2. So I1 you can see is very simple. This voltage applying here. So we can say I1 is the voltage divided by the sum of the two. So that is I1. Similarly, I2. Total voltage and divided by these two impedances. So Z minus 65. Solving with the help of your calculator in complex mode, this is the value. And this is the second value of current. And now we'll take the KVL around upper loop I'm taking. And I'll go like this from positive terminal. So J10 I1 plus V Thevenin minus J6 I2. From here, V Thevenin is this value. Plugging in the values of current I1 and I2 and solving, V Thevenin is 52.43, angle 165.96. So we have found both the parameters, so we can draw the Thevenin equivalent circuit. This is the voltage and this is the impedance. So this is first part. Calculate the load to be connected across AB for maximum power. So we have learned that for maximum average power transfer, the load impedance ZL must be equal to the complex conjugate of the Thevenin impedance. So ZL has to be complex conjugate of Z Thevenin. So our Z Thevenin is this value. So to make it conjugate, we just change this sign here. So ZL will be same value with changing sign, plus sign. So this is ZL. This is part C done, and now part B, find the P maximum, value of the maximum power dissipated. So this is the formula we have learned from the book, is V Thevenin square mod divided by H R Thevenin. So we take the mod of the value of this and 8 and R Thevenin, we get the first part is the real part, that is R Thevenin. And so the answer is 78.45 watt. So I hope you have been able to follow this. Please let me know through your comments. Thank you.